Welcome to All Things Data Science, the one-stop channel to help anyone interested in learning or transitioning to data science, just like I did. Today we have another LeetCode series example. It's around linked lists. It's in the category of easy, and it's called Remove Duplicates from Sorted List Problem. I'm going to start with just an implementation I had. It actually runs at the equal time to the one that I'm showing later. It just the later one has sort of less pointers and is a little bit more concise. So what's the problem set that we're dealing with today? Basically self-explanatory from the title itself, and as you can see, it's a one-liner. If you have any duplicates, i.e. nodes that are repeated, then just remove them, and that's what you return. So you are still returning a linked list. One thing that I thought was really important, I forget, I guess I put it over here. I like writing little notes to myself as I'm coding stuff up, that way I remember them, is because this is a sorted linked list, you're not going to encounter, for example, a case where you've got 1, 1, 2, 3, 3, and then another one over here. So that's not going to happen. So that's great, because at some point I was thinking, all right, maybe like a hash table or something to keep track of things. So instead, you could just use comparisons in order to move forward. So this is why the one I'm going to show later is a little more concise. Here, I just like having very explicit pointers or specific to certain things, and then having extra bits like this particular section here. I just like when I start coding to make it very clear in my head what the edge cases are. So in my mindset, it's, you know, if I had an empty one, or if I had something that just had one element, then you just return that itself. So let me take care of that, get it over with. That's sort of the way I think about it here. And then we move on to the more interesting bit. So here I went about thinking about this where I was building the linked list one by one, but there's a more concise way that I'll show later. So for me, there is a result is what I'm going to be returning at the very end. So we've got that. And the reason I make it equal to this sort of temporary part is I want to make sure that whatever we're going to end up with at the end, I just want my result specifically to always be pointing at the beginning. And that's sort of what gets returned over here. So that's the purpose there. And then the temp is the one that I'm going to be sort of carrying around. What does that mean? I'm actually looping through the head. So basically, if we're starting over here, then our head is in here in particular, and we say the little conditions, okay, we have none of those. So we move on and do two things. I start building my little temp linked list. So I say, all right, give it the very first element. I'm gonna take a 1 in there. And then I move on, where now the header of this is now pointing to this, which happens to be another 1. And I come in here. The value was a 1. The previous, we saved the value that we had before, so 1 to 1. So we were not going to enter over here since they are in fact equal. And basically now your previous becomes this new value, and the head now gets to move on once again. And we keep on going. When you do have an instance like the particular one we're in, where indeed previous is 1 and then head value right now is the number 2, then indeed the previous was less. What I personally do is for temp, I say, okay, now and only now do you get to add another node. So I'm just building it as I see valid cases. And if it wasn't, then it's just going to skip that step. So if it was equal, it's just not going to add something to it. And so basically we then add the 3 and we kind of just stop there, right? And then there's always just making sure that when you're done with the while loop, did you fix everything? And what I mean by that is, as I was going through, I was always looking at what head equals to. So basically at this very last step, when I say head.next, now always by default, based on the definition, the last sort of next is pointing to a none. So that's what we really have. So then eventually I have head is here. And therefore I have indeed looped all the way to ending at a statement that gave me a none, and therefore I do not enter this bit once I'm at the very end. And I've got my little nicely formed temp. The temp, however, because it's also sort of looping through, at the end it won't be obviously at the beginning, but nice thing is we kept our little result that was always pointing at the beginning of the linked list, and hence when we return it, it does return the full linked list that is now nice and without duplicates. So that's the approach I'm doing over here. If that feels sort of a little bit wordy, then basically when we do go, and this solution is, I think, open to everyone, it only has the Java one, but you could see that the formatting is going to be very similar to the Python code I'm looking at. I think someone exactly, even in the initial solutions, talks about this, but here is one in particular, and I guess to give people actual credit, let me just run this for us to see it. At least earlier, so 98, earlier, full disclosure, it was 70 something, so I don't know if it goes by the speed of the internet. But this one I liked. It's very, again, similar to sort of the Java suggested approach. But here, and we could sort of run it, if we actually, it was just run, so 77. But basically here, instead of having the temp and the result and as pointers, again, to me, they make a little more sense. But this is a lot cleaner, and you're sort of maybe not creating one node at a time. It doesn't bother me, and as you saw, the speed was pretty similar. But here, basically, you're not going to be touching head, and instead, the current is what you're moving through. But I really like this little bit specifically. One, this is just generally, I think, cleaner to just say if the next node is not none, basically, if it's none, it would have been false. So it's just like a nicer way instead of writing the, does not equal to none. So if you see that without like a Boolean, that's what these things are doing. And here, basically, it's automatically kind of peeking ahead and saying if the next value is equal to the current one, i.e. we do have a duplicate, then just go ahead and skip it. So that's what this is doing with the next, which is nice. And then you could just move on with your current next. But then always, you cannot return, similar to me having earlier to go back to result, the one that was not touched. This is what's happening over here. At the end of the day, you gotta pick the one where the pointer is pointing at the beginning, because otherwise here you're sort of chopping through as you're going. And that's pretty much it. So that is what I would call the better solution. The latter one more from a just conciseness perspective. So hopefully this was interesting. If you have any questions or comments, please leave them below. And if this is interesting to you overall, please subscribe. But recommendations are really what I'm looking for what you'd like as next content. Thank you very much. Bye-bye.